Welcome to part one of our quiz from May 21st, 2021 for astronomy. It is a star has a luminosity that is known to be 4.8 by 10 to the 29 watts. A scientist observing this star finds that the radiant flux intensity of light received on Earth from the star is 2.6 nanowatts per square meter. Name the term used to describe an astronomical object that has known luminosity. So for all the students that were enjoying senior skip day, but were mindful enough to log on to YouTube and get their work done and finish their quiz, you might have noticed that the title of the quiz was the Standard Candle Quiz, and so that's the name of the term, the Standard Candle. Determine the distance of the star from Earth. Here you may recall that the luminosity of a star is equal to, or rather the flux of the star. This is like where we got our TF symbols from yesterday, or we're doing the quiz like false, or is it true? No. The flux, right? So that's how much light we sort of receive here on Earth, is going to be equal to the luminosity divided by 4 pi d squared. Remember, this is the equation for flux because the power of a star, its true brightness, its luminosity, is spreading out sort of in all directions, right? And it's really three-dimensional, so it's a sphere. And so as we get further and further away, a greater distance from the star, that radiant energy has spread out over a bigger and bigger sphere. And so here on Earth, we're just detecting a small fraction of this entire sphere. And so this is the surface area of a sphere, right? With radius sort of d here, so that allows us to solve for distance. This we can measure on Earth, right? This is just how much brightness hits each square meter of our telescope, of our collecting area. So this is always measurable on Earth. It's how bright does it look to us, right? It's apparent brightness, it's flux. If it's a standard candle, it has known brightness, right? Its luminosity is also known. And so this allows us, this is all we need to work out how far away it is, right? So let's rewrite this. First, I want to rewrite it like 4 pi d squared f equals L, right? Multiply both sides by that term. And then let's divide by 4 pi f. And then we want to take the square root of that, right? So like get rid of these 4s, get rid of these pi's, get rid of these f's. And so if we take the square root, just did all my algebra in one step there. Math teachers the world over are cringing. That's not good form. If you're comfortable with the algebra, if not, write it out every step. Don't make a mistake there, right? All right, so now let's substitute in some values. The luminosity, 4.8 by 10 to the 29 watts. 4 pi, the flux, 2.6. All right, nano, 10 to the negative 9. Okay, we can just substitute. Nano means billionth, and so that's this order of magnitude. And then it's going to be watts per square meter. So I'll just move that back to the numerator. When I take the square root, these watts will cancel underneath the radical, but the square root of meters squared will be meters. So the units always work out. That's nice. It will kind of show if you set it up correctly, the units will work out to give you the correct solution. And now it's just a matter of punching the buttons correctly. Let me show you that with the on-screen calculator for the benefit of everybody. All right, got my scientific calculator. Put it sort of right over here. That's kind of visible. Let's clear up some of this. All right. We're going to start with the numerator, 4.8 by 10 to the 29. There you go, in standard form. That's a good calculator there. All right, divided by 4 equals, I like to hit equals along the way, you guys. Divided by I equals, divided by, here you must open parentheses to divide by the entire quantity, 2.6 by 10 to the -9, when you close parentheses, there's my 2.6 by 10 to the -9. That's the thing I want to divide by, right? If you don't use parentheses, then you'll divide by the 2.6 first and then multiply by a billion. And so, you don't want to multiply by a billion, you're dividing by 2.6 billion, right? And so that's wildly different answers. And so this is what we get under the radical, right? So that's what we get under the radical. We still got to take the square root. So a convenient way to take a square root is to raise something to the 1/2 power. So if I raise it to the 0.5 power, that's the same thing as taking a square root. Equals, and I get a final answer of, I'm going to write it all out here. 3, 8, 3, 2, 9, 1, 3, 4, 5, 0, 1, 2, 8, 3, 6, 8, 6, 1, 4. We'll round it there to the ones place. All right, can we read this number? Let's see here. Million, billion, trillion, quadrillion, quintillion. It's just 3 quintillion, 832 quadrillion, 913 trillion, 450 billion, 128 million, 368,614 meters away. We convert that to light years or something, maybe a parsec or gigaparsec or something. And so that's obviously way too precise. Like we know it to the exact meter how far away it is. And so this is a calculator value, right? This would be way over reporting the precision of my answer. And so if we look at like 2 significant digits, we should probably round this to 3.8 times 10 to the 3, 6, 9, 12, 15, 18 meters.